Okay, so this is question 6, the last question of assignment 3, and it wants us to prove that this limit, when n goes to infinity, this fraction here equals to 0. So how do we do that? All right, so we want to let epsilon be greater than 0, and we want to choose a value m, which is a natural number, such that m is less than, sorry, m is such 1 over m is less than, because it's a fraction, so we want to choose 1 over m is less than epsilon, right? And if we find a value, denominator here that's smaller than this denominator, sorry, a denominator here, so 1 over something, 1 over n that's smaller than or equal to 1 over m, then we will have proven that 1 over n is smaller than epsilon, and thus uh, the limit approaches the limit when it goes to infinity would be equivalent to 0. All right, so let's just try to factorize the fractions and see if we can get a value for m. So this would be equivalent to this squared. If we just factorize it, 101, right? So we want to choose a 1 over m that's bigger than this value here, and let's say let this value here be bigger than or equal to m, right? So if you take the reciprocal of this numbers here, 1 over n would be smaller than 1 over m, right? So let's just choose, oops, let's just change it to capital M, and m equal to m. Then for all n, n is always greater than or equal to m. This implies that if we take the limit, we take this 1 over denominator minus the limit, we get this 1 squared plus n plus 101, which is always less than or equal to 1 over a n plus 101, which is always less than epsilon. Thus, we have shown that the limit as n approaches to infinity of this fraction here would equal to 0.